Good morning, learners. I would love to welcome you today to our first chemistry lesson. And in this lesson, we are going to look at limiting reagents. In narrowing down this topic, we have to look at two definitions that are most important for us to understand. And the first one is defining what the limiting reagent is. And the second one, which we need to take note, is what is an excess reagent. So defining a limiting reagent, we say it is a reactant that is short supply by the mole ratio, and hence it finishes before the other reactants are completely reacted. Then we also need to take note that excess reagent is a reactant that remains unreacted at the end of the reaction. So trying to explain these two concepts is that when we talk of a limiting reagent, it will limit the number of products that can be formed, and it also limits the number of mole ratios that can react with the other reactants. When we say excess reactant, we mean that the other reactants remain unreacted because the limiting reagent has finished, meaning the reaction won't go into completion, hence determining the number of products that can be formed. There are two methods, or there are 2 points that we would want you to take note on how to identify a limiting reagent. So identifying a limiting reagent, one, you need to have a balanced chemical equation and the mole ratio of the reactants which are going to be used. Second, as a learner, you don't need to use the volumes, concentration, or the masses of the reactant. This is because it is going to confuse you. So on the first point, remember you need to have your chemical equation balanced in order for you to find which of the two reactants, or even more, would be the limiting reagent. So having looked at this, I can take you to an example that you need to understand. So example number 1 that you need to know is that 19.6 grams of zinc and 4.90 grams of sulfur were heated together. Which of the two is a limiting reactant? That is A. B. How many moles of zinc remain unreacted? Then C. How many grams of zinc element remain unreacted? So to look at this, we will try and answer these questions, which are simple questions for that matter. So the first thing that you need supposed to do in this method, which we are going to call method 1, is that you need to find the number of moles of zinc as well as the number of moles of sulfur. So finding the number of moles of zinc, we say number of zinc is equal to mass over molar mass. So we'll say the mass which we are given in the question, which is 19.5 grams over 65 grams per mole. When you go on your periodic table, you find the zinc right there, which is 65 gram per mole. Hence, after that is done, we'll divide, then we are going to have 0.3 more. Same applies for sulfur, which is 9.4 grams. Divide by 32 gram per mole on your periodic table, we are going to have 0.9. The number of moles for sulfur are less than that of zinc. So sulfur becomes the limiting reagent because it is limiting the number of products that can be formed. Then following it up, looking at B, which was asking us to find the number of moles of zinc that are reacted, meaning that the number of moles of zinc that we had calculated in first minus the number of moles of sulfur. When you subtract the two, we are going to have 0.01 moles of zinc which is unreacted. Then as for B, we are now asked to find the mass of zinc that remained unreacted. So the formula is number of moles times molar mass. Then we have 0.01 number of moles of zinc that was unreacted times the molar mass, which is 65 gram per mole. Then when you multiply the two, you are going to have 0.65 grams per mole for zinc that remained unreacted. Thank you for finding time to watch this video. Look out for more videos coming up, and remember to subscribe to my YouTube channel. Thank you very much.